This AstroPictionary Math problem, we want to look at age of stars on the main sequence. We're given the age of the solar system is 4.6 billion Earth years. We're also given main sequence stars A, S Monocerotis, capital A, small a, which has a mass of 29 solar masses, and B, the Sun, which has a mass of 1 solar mass. We want to find the age of these stars on the main sequence for both of these two stars, S Monocerotis, capital A, small a, and the Sun. We're also given an equation where T is approximately equal to, open parentheses, M divided by solar mass, close parentheses, to the minus 2.5 power, times 10 to the 10th Earth years. So let's see how we can solve this. Let's first solve for S Monocerotis. T is equal to approximately the mass. So we want to substitute in for the mass. We have 29 solar masses. We want to substitute in. So we put 29 and solar masses. Always keep the units with the star and the number, and divide it by a solar mass. Now we have to take this to the minus 2.5 power, and then we have to multiply it by 10 to the 10th to get us Earth years, which I'm just going to abbreviate YR for short. So let's get rid of like variables. So we have solar mass eliminates solar mass, and now we're left with 29 to the minus 2.5 power. So let's go and multiply that out. We look for a calculator on Google or your favorite search engine. We type in 29 x to the y minus 2.5, and we get a value of something very small. Let's take a look at our values. We have 29, which is 29.0, and we have 1 or nothing in the denominator. We got 10, which is basically 10.0. So we have 3 significant digits. So we can go 2.21, because 8 is greater than 5. It kicks the 0 up to 1. 2.21 times 10 to the 1, 2, 3, 4. 10 to the minus 4. So we end up with a value of 2.21 times 10 to the minus 4. And then we have to multiply that by 10 to the 10th years. So all we do is multiply. Now this 10 to the 10th is really 1e10. So we multiply by 1e10. We hit equal. We have a value of, remember we can only keep 3 digits, 2.2, this 8 kicks this to 1, so 2.21 to the 1, 2, 3, 4, 5, 6, to the 10 to the 6. So we have a value of 2.21 times 10 to the 6 years, or 10 to the 6 Earth years, since we're basing it on the Earth year. And since 10 to the 6 is a million, we have around 2.21 million Earth years. And that is the age that this particular star will sit on the main sequence. After 2.21 million Earth years, it'll eventually evolve off the main sequence. Now let's take a look at the Sun. Same equation. T is approximately equal to, and we substitute in for mass, which is 1. We already know that solar mass is going to eliminate with solar mass, so I'm not going to put the units in, to the minus 2.5 power, and multiply it by 10 to the 10th, and our units are going to be Earth years. So we automatically know that 1 divided by 1 is 1. 1 to the minus 2.5 power is just 1. And we have now 1 times 10 to the 10th as our answer. And our units are Earth years. So the age of the solar system is 4.6 billion Earth years. So let's put this in terms of billion. So T is around equal to, we have to subtract out or divide out by 1,000,000,000, which is 10 to the 9th, in 1,000,000,000. So I build my railroad track up at an angle, since we're running out of paper. So now we just need to divide 1E10 is what we have, divided by 1E9. So we're left with 10. So we're left with 10 billion Earth years as our answer. Now we know that the age of the solar system is about half of this. So that means the sun is about halfway through living on the main sequence, happily fusing hydrogen and helium in its core. After another about 5 billion Earth years, the sun will start to evolve off the main sequence.